Welcome to
Nay.
Do it.
Channel Everyone. Okay, wow, that was surprisingly in sync for us. I'm Isabel, and today we are diving into one of my favorite kinds of topics, trying to see inside the AI's head. Because honestly, sometimes it feels like magic. We type something, and poof, an answer appears. But how does it decide what's important in what we wrote?
Exactly, Isabel. That's the core question. We call these models black boxes for a reason. We see the input and the output, but the reasoning in between is opaque. For years, researchers have used tools to visualize attention, basically showing which words the model is focusing on when it generates the next word.
And those tools are crucial, but let's be real, they often come with a cost. Many are built for one specific type of model architecture, the transformer and the common method, using backpropagation. It doubles the GPU memory you need. It's computationally expensive, not exactly lightweight or accessible for everyone.
So we need an X-ray machine that works on any patient and doesn't use up all the hospital's electricity. Got it. What's the new approach?
The paper we're discussing introduces VISTA, a model-agnostic, efficient method. The key idea is elegant in its simplicity: perturbation. You systematically remove one token, one word or piece of a word, from the input.
Then you ask the model to generate its output again. You compare the new output's meaning, its semantic vector, to the original output's meaning. The bigger the difference when you remove a word, the more important that word was.
Hold on. Compare the meaning. That sounds fuzzy. How do you measure a change in asterisk meaning mathematically? That's the part that always makes my brain glitch.
A very good question. This is where the paper gets clever. They don't just use one measurement. They use a framework of three matrices, three different lenses to look at the change. First, the angular deviation matrix. Think of the meaning as an arrow in space. When you remove a token, does that arrow point in a different direction? This measures a shift in the asterisk type of meaning.
Second, the magnitude deviation matrix. Does the arrow get longer or shorter? This measures a change in the asterisk intensity asterisk or confidence of the meaning. Third, the dimensional importance matrix. This looks across all the individual dimensions of that meaning vector, hundreds or thousands of them, to see which specific features were most affected by removing the token.
Okay, so you have these three different scores, for direction, for strength, and for detailed features. Then what? You just average them.
Not quite a simple average. They combine them into a composite importance score. It's a weighted, nuanced blend. This gives you a relevance map, a heat map over the original text. The hotter tokens are the ones the model found most critical for producing its specific answer.
And the best part, no backpropagation. You just run the model forward a few times with slightly different inputs. The computational cost is minimal. It works on any model that gives you a semantic vector for its output, which is almost all of them now. It's a Swiss Army knife for interpretation.
That is seriously cool. So this is like, instead of trying to trace every single electrical signal in the brain, you just gently tap different areas and see how the person's story changes. The areas that cause the biggest story shift are probably the most important for that particular narrative.
That's a perfect analogy, Isabel. A gentle tap, a perturbation, to infer function. And because the code is open source, anyone can try this. Researchers, developers, even curious students. It lowers the barrier to understanding these systems we're building.
Which is essential. As these models get more integrated into everything, we need more tools like VISTA, tools that are efficient, adaptable, and help us ask not just what does it do, but why did it do that? It's a step towards more transparent and accountable AI.
I love it. From black box to slightly grayer box, a box with some helpful labels on the outside. Thank you, JJ Jiyoung, for climbing that ladder with me from magic to perturbation matrices.
Thank you, Isabel. Always a pleasure.
Thanks for having me.
And thank you all for watching. We'll see you next time.